What do you think of when you hear the word paging? Do you think of something like this?
Paging. Paging system ready.
Or something like this?
Calling Dr. Howard. Dr. Fine. Dr. Howard. Calling Dr. Howard. Dr. Fine. Dr. Howard.
Well, the type of paging we're here to talk about is operating system paging, which is how a process is split. In operating systems, paging is a memory management scheme by which a computer stores and retrieves data from secondary storage for use in main memory. The main idea behind paging is to divide each process in the form of pages, while physical main memory will be divided into frames. In this example, we have 3 processes over here. Each process uses the stack, sparse address space, heap, data, and some code. In this memory management scheme, the operating system retrieves data from the secondary storage in same-size blocks called pages. Paging is an important part of virtual memory implementations in modern operating systems, using secondary storage to let programs exceed the size of available physical memory. Here we have 2 processes shown split into 8 pages, a page table, and on the right side, the main memory, or RAM, with a number of frames. One page of a process is stored in one of the frames of memory. Hey, are you paying attention? Well, here's an example using delicious Hershey's chocolate as an analogy to represent the pages and frames. The individual bars on the left are representing pages, each being of equal size, while the bars that are still together on the right represent main memory, or RAM, as a whole, and each of the individual bars are representing frames that are equal in size to one another, as well as the same size as the pages being brought into them. Now don't get too distracted by the delicious chocolate. Now it's time to see more of the video. Moving on. Memory does not have to be allocated in a contiguous fashion. Pages of a process are brought into main memory only when they are required. Otherwise, they reside in secondary storage. Paging also helps prevent external fragmentation. Logical address space in virtual memory is divided into equal-sized pages, while the physical address space in main memory, or RAM, is divided into equal-sized frames. Because pages are mapped to frames, the page sizes and frame sizes need to be the same. The memory management unit uses page tables to convert a logical address into a physical address. This maps the pages in virtual memory to the frames in main memory. The logical address contains the page number and offset, while the physical address contains the frame number and offset. Page tables require extra memory space, so they may not be good for a system that doesn't have a lot of RAM. So as you can see here, the page table for process 1 is showing that page 2 of process 1 will be placed in frame 12 of main memory, while page 3 of process 1 will be placed in frame 5 of main memory. Also, process 2 has its page 4 in frame 5 of main memory, which means this is shared. Page 8 of process 1 will be located at frame 10 of main memory. Page 6 of process 2 will be located in frame 7 of main memory. Page 1 of process 2 will be located in frame 11 of main memory. This is basically how paging works, splitting processes into smaller pages. Bite-sized, that's B-I-T-E, not B-Y-T-E. Similar to a chocolate bar.
Paging. Paging system ready.
Calling Dr. Howard. Dr. Fine. Dr. Howard. Calling Dr. Howard. Dr. Fine. Dr. Howard.
Thank you for watching our video, and we hope you have a better understanding of paging now. If you are looking for more information, check out our sources. Have a nice day.